I would like to make a presentation of this two-volume series on quantum physics that I wrote because I felt something was missing. Something was missing among so many books on quantum physics. Namely, something that gives an overview of the whole subject available to the public, but at the same time does not present a distorted image of it. I felt it necessary to create something that tells first of all the facts. And there is probably no science that is as confusing as quantum theory. There is so much misleading information on the subject that for most people it is very difficult to separate science facts from pseudoscience. The goal of this book, of these two volumes, is to make you able to separate facts from fiction with a comprehensive overview and introduction to the scientific principles of a complex topic in which meaning and interpretation never cease to puzzle and surprise. Let me begin with the first of these two volumes. It introduces the basics of the conceptual foundations of the 20th century quantum physics. It appeared first as a series of video lectures on the online learning platform Udemy. You can find all the links to the books and the video courses below. And it is an A to Z guide which is neither too advanced nor oversimplified to the weirdness and paradoxes of quantum physics explained from the first principles to modern state-of-the-art experiments, and which is complete with figures and graphs that illustrate the deeper meaning of the concepts you are unlikely to find elsewhere. It is a guide for the autodidact or philosopher of science who is looking for general knowledge about quantum physics at intermediate level, furnishing the most rigorous account that an exposition can provide and which only occasionally in few special chapters resorts to a mathematical level that goes, however, in any case, no further than that of high school math. It will save you a ton of time that you would have spent searching elsewhere trying to piece together a variety of information. What I try to do is also to span, so to speak, an arch of knowledge without giving into the temptation of taking an excessively one-sided account on the subject, except perhaps on the last chapter where I go into the question of philosophical idealism. So the questions that I try to answer with this book is: what is this strange thing called quantum physics? What is its impact on our understanding of the world? What is reality according to quantum physics? This book addresses these and many other questions through a step-by-step journey. It describes the central mystery of the double-slit experiment and the wave-particle duality, the fuzzy world of Heisenberg's uncertainty principle, that weird Schrödinger cat paradox, the spooky action at a distance of quantum entanglement, as Einstein used to call it, the so-called EPR paradox, and much more are explained without neglecting such main contributors as Planck, Einstein, Bohr, Feynman, Pauli, von Neumann, and so on, and others who struggled themselves to come up with the mysterious quantum realm. And we will then conclude this first volume by making some considerations on why and how quantum physics suggests a worldview based on philosophical idealism. It is a treatise that goes at times into technical details that demand some effort and therefore requires some basics of high school math, such as calculus, algebra, trigonometry, some elementary statistics. However, the final payoff will be invaluable. Your knowledge of and your grasp on the subject of the conceptual foundations of quantum physics will be deep, wide, and outstanding. Additionally, because schools, colleges and universities teach quantum physics using a dry, mostly technical approach which furnishes only superficial insight into its foundations, this manual is recommended also for all those students, physicists or philosophers of science who would like to look beyond the mere exclusively formal aspect and delve deeper into the meaning and essence of quantum mechanics. This style is maintained also at a bit higher level in the second volume, and which is a continuation of the first volume's 20th century conceptual foundations of quantum physics, extending its view to the principles and research fields of the 21st century. This is also a very comprehensive, deep and wide guide on topics that usually aren't explained at introductory level elsewhere, and that might you help in saving again a lot of time to search for it piecewise elsewhere. It fills the gap between a too popularized version of quantum physics and the too high-level university textbooks. It is a review of the standard concepts from modern advanced experimental tests of what I called quantum ontology to the interpretations of quantum mechanics, the standard model of particle physics, and the mainstream quantum gravity theories. It is a state-of-the-art treatise that reports on the recent developments in quantum computing, classical and quantum information theory, the black holes information paradox, and the holographic principle to quantum cosmology, with some attention on contemporary themes such as the Bose-Einstein condensates, as also to the more speculative areas of quantum biology and quantum consciousness. All topics are explained with a concise but rigorous intermediate level style. In an era when the conflict between the so-called quantum woo versus material physicalism is raging, both sides should first gain clarity of concepts to avoid confusion and jumping to unwarranted conclusions. Considering how the media, sometimes also physicists, present quantum theory, which focuses only on highly dubious ideas and speculations backed by no evidence, or worse, promote pseudoscientific hypes that fall regularly in and out of fashion, this is a vademecum, so to speak, for those who look for a serious introduction and deeper understanding of the 21st century quantum physics. You will finally learn the basics, enabling you to distinguish between the real science backed by experimental facts and just simple speculative interpretations. These two volumes can be useful not only for the autodidact, but also for physicists who could rediscover some topics, as also for philosophers or historians of science, engineers, IT students who could acquire a basic preparation which is unlikely to be offered in most departments. So, if you would like to know more about it, you can find the link to the Amazon website below, and where you can also browse through some pages. So, I hope you will enjoy it.